This story takes us back to the year 2006, when scientists across the world detected a dangerous gas rising in our atmosphere. That gas was methane. They noticed that its levels had suddenly jumped higher than expected, and they are still climbing to this day. Methane is a type of natural gas. When it escapes into the air, it traps heat around the Earth, like a giant blanket. Think of it the way we cover ourselves in winter to stay warm. Methane does the same thing, keeping the planet's heat locked inside. And here's the worrying part. Methane heats the Earth far more powerfully than carbon dioxide. So when scientists saw this sharp rise in 2006, they assumed it was caused by human pollution. But what they discovered left them stunned. They realized our planet was hiding a secret deep inside itself, a secret about methane, and why it was suddenly pouring into the sky. The scientific community already knew one fact. Methane spikes in the atmosphere usually happen once every 100,000 years. How do we know this? From the ice. In frozen places like Antarctica and Greenland, scientists drill deep into the ground and pull out ice cores. Each year, a new layer of snow falls, and in that snow, tiny bubbles of air from that year are trapped. Over centuries, the snow builds up, and when scientists extract those deep layers of ice, it's like opening a time machine. Inside are frozen records of the atmosphere, stretching back thousands, sometimes millions, of years. And from those bubbles, scientists can measure exactly which gases were present and in what amounts. Through this method, they discovered a pattern. Every 100,000 years, methane levels rise dramatically, and that spike signals the end of an ice age. When an ice age begins to end within just 2,000 to 3,000 years, huge sheets of ice melt and Earth warms to conditions much like today. But here's the problem. The last methane spike was recorded 12,000 years ago. That's when the most recent ice age came to a close. So why are methane levels rising again so soon? Are we on the edge of another massive planetary change? Or is this something entirely new and even more dangerous? To find answers, we need to step back into Earth's history. Right now, we live in what scientists call the Quaternary period. It began 2.5 million years ago and continues today. This period has two main parts. The first was the Pleistocene epoch, which lasted until about 12,000 years ago. It was an age of repeated ice ages. Vast parts of Earth froze, then thawed, then froze again. This was the time when humans evolved, and when mighty animals like the woolly mammoth vanished. Then came the second part, the Holocene epoch. It began 12,000 years ago and is still ongoing. During this era, the ice retreated, the climate stabilized, and the Earth warmed. This stability gave humans the chance to farm, to settle, and to build civilizations. But here's something surprising. Technically, we are still in an ice age. Why? Because the polar ice caps still exist. An ice age is only truly over when all the ice at the poles is gone. So what exactly warms the planet enough to melt that ice? Scientists discovered three great cycles, together called the Milankovitch cycles. The first is eccentricity. Earth usually orbits the Sun in a circle, but sometimes the orbit stretches into an oval shape. When that happens, Earth receives more solar heat at certain times. This cycle lasts about 100,000 years. The second is axial tilt. Earth is tilted about 23.5 degrees, but that tilt slowly shifts between 22.5 and 24.5 degrees. When the tilt is stronger, the poles get more summer sunlight, and ice melts faster. This tilt cycle takes 41,000 years. The third is precession, the slow wobble of Earth's axis like a spinning top. This changes the timing of the seasons. It takes between 19 and 23,000 years. Together, these three cycles begin a chain reaction of warming. When ice melts, its bright white surface disappears, and darker soil or ocean absorbs sunlight instead of reflecting it. More heat means more melting, and the cycle accelerates. As Earth warms further, gases like carbon dioxide and methane, once trapped in ice and oceans, escape into the atmosphere. These gases amplify the heat even more. So back to the mystery. If this is the natural rhythm of Earth, why did methane surge again in 2006, just 12,000 years after the last spike? In the 20th century, the natural gas industry did increase methane emissions, but by the 1990s, levels had stabilized. So where did the new spike come from? Methane isn't only man-made, it's also produced naturally. Vast amounts lie frozen under oceans and locked in permafrost. When warming melts these layers, methane escapes. Modern satellites can now detect these leaks. They send down laser beams of a special wavelength. Methane absorbs that light. So wherever the beam fails to bounce back, scientists know methane is present. Using this technology, researchers mapped methane hotspots across the planet. They discovered a massive methane cloud above a landfill in Iran, 3 miles long. That single site releases more than 73,000 tons every year. That's equal to the weight of 180 jumbo jets, or more than 8,000 kilograms every single hour. Even larger leaks were traced to Turkmenistan, where 12 oil and gas sites release about 400 kilograms per hour each. But scientists say this explains only a fraction of the surge. The bigger culprit lies in melting permafrost. As it thaws, ancient plants and fossils trapped inside decompose and release enormous amounts of methane into the sky. And here's the danger. Once methane enters the atmosphere, it's almost impossible to capture. At landfills or gas fields, methane can be collected and used for energy. The byproduct is carbon dioxide. Harmful, yes, but far less potent than methane. But the methane seeping out of forests and thawing tundra, it cannot be collected at all. Methane lingers in the atmosphere for about 10 years before breaking down into carbon dioxide and water vapor. Here's the most unsettling truth. Every time in history that Earth released methane at this scale, it marked the end of an ice age. But today, glaciers have already melted dramatically, and yet methane is spiking again. This has never happened before in Earth's recorded history. So what does it mean? Is our planet heading into a brand new phase? Or are we moving toward another ice age altogether? The truth is, no one knows. Scientists have no reference point in Earth's history for a methane surge so soon after the last one. No one can say how high the levels will rise. And if the cause is natural, not man-made, then stopping it may be impossible. What we do know is this. If methane keeps climbing, it could trigger one of the greatest climate shifts our world has ever seen.